Hi guys, welcome to Unit 4, Lesson 7, Graphs of Proportional Relationships. So in the last lesson we talked a little bit and we reviewed slope, which was a concept from previous grades. So proportional relationships, we've talked a lot about constant of proportionality, right? That's what makes the different ratios equivalent, and in this case ordered pairs, which is still a ratio. You're comparing one point to another. And so constant of proportionality, it starts with slope. And I put that on here because, one, that's how you can find the constant of proportionality. But there's some other important things too. It also has to pass through the origin, okay, or point 0, 0. And it has to be a straight line. If it doesn't have those things, it's not proportional. So this first example, I didn't even count it as like one of my official examples, but this will help you with number 3 and number 4 on your quick check. Okay? So I have 3 super basic graphs set up for you. This first one, so like here's my x-axis, here's my y-axis, right? Well, this one right here, it's a straight line, which means I could find a slope from it. And it passes through 0, 0. So this would be proportional. Okay, that one has the ability to have a proportional relationship. This one here, again, here's my x value, here's my y value. This is not proportional because it does not pass through the point 0, 0. Okay, so that's a huge and important thing that you need to understand looking at these basic graphs. This one right here, this is not proportional for 2 reasons. One, it doesn't go through the origin, right? This is the origin right here where the 2 axes meet. That's your origin. So this one doesn't go through there, and it's not a straight line. So therefore it's not proportional. Okay, so number 3 and 4 on your quick check, those are very important. All right, with this first example, this is number 1 from your practice. Okay, number 1 from your practice. And so we've got this graph set up, and on the graph, and it's actually set up like slightly different than how I set it up, so I apologize for that. It doesn't have like the odd marks, tick marks. It only has the evens. So like this one right here wouldn't be here, actually. Okay. So, but they want us to find the unit rate, and let me actually pull it up so I can read it to you, so you can know what I'm referring to. So they give you a big graph, and then it says the stretch of a spring in millimeters is proportional to the weight in grams attached to the end of the spring. Find the unit rate. Okay, so there's lots of big words there, but the biggest thing that we're looking for, and the very first point that is listed on the graph is this one right here. They give you other ones that are further up. We actually don't need them. So this point is point 210. Well, if I'm looking for the unit rate, remember I want it to be out of 1. Okay, so with that, usually how this would be listed in ratio form would be millimeters out of grams. So we're looking for out of 1 gram, how many millimeters, and that's how the question is listed. Okay, it's millimeters to grams, millimeters to grams. So we want it to be out of 1. Well, right now this is millimeters and grams, right? So I could say, okay, well, I'm going to bring my 2 down here and my 10 up here, right? And now I've created a proportional relationship in saying I've got grams to grams, millimeters to millimeters. Well, if I want this to be a 1, I can divide 10 by 2, okay, or divide both by 2 really, but dividing 10 by 2 will give me a 1 in my denominator, and 10 divided by 2 is 5. So here is your unit rate, 5 millimeters per gram. And I believe on your practice, you only have to enter in the number 5. Okay, but this is what it's looking for. That's the process that you would take. Okay. All right. With this second problem that I'm going to do, because I already helped you with number 3, I already helped you with number 4 on your quick check. So here's number 5. So I'm giving you quite a bit of help on that quick check. Now this one, they give us a graph, and I can read the entire problem to you. Give me one second, I'll get back to it on my other screen. It says the table shows a relationship between the amount of time spent walking, there's that, and the number of calories burned. Determine if the relationship is proportional. Okay, so what we want to do in order to figure that out, we could take calories burned, we say calories burned per minute, right? Those minutes, excuse me, the minutes that if it's per minute, it's per 1 minute. And remember in those, the constant of proportionality or the unit rate, different things like that, there needs to be that 1 in the denominator. So if this were the case, we could say, well, there's 100 calories burned per 20 minutes, right? So in order to find the unit rate or the constant of proportionality, whatever you want to refer to it as, we could divide 100 by 20. Well, 100 divided by 20 is 5. So that unit rate is 5 calories per 1 minute. Well, then with that, what we would want to think is, okay, well, if I multiply the minutes times 30, and then I would have to multiply the calories by 30. 5 times 30 is 150. If I multiply my minutes times 40, well, I got to do the same thing to the calories. 5 times 40 is 200. If I multiply my minutes by 60, right, I got to do the same thing to the calories. 60 times 5 is 300. And the same would be true with the 80 and the 400. So therefore, the answer would be yes, this is proportional. Okay? The other thing I should have listed on this problem here, this one, remember it's unit rate, or it's the constant of proportionality, or sometimes it's also referred to as the K value, okay, which is also like scale factor. So if you see that in there, don't be surprised. All right? I hope this helps, and reach out if you need extra support.